Hello. All right, let's get started. I am going to start by showing you notes that we took today. In class, I did it backwards. We did the examples first, and then we did notes second. We're going to do the notes first, and then the examples second. A couple of ways you can do this. You can copy it all first and then watch this part of the video as I go through it, or you can copy as I go through it. But I will be going fairly quickly, so be prepared to pause. Start on the very first page of your notebook for semester 2. You can title it nice and big Module 7 if you like, since this is the beginning of our Module 7. This is for Module 7, Lesson 1, Composition of Functions Steps. Today is the 13th of January for us, 2026. So first step is to write the function of x and the g of x equations. They're going to give you two. Write them both down. 2, predict the shape of the graph. And we'll talk about what clues there are to the graph from the equations. Number 3, write the composition order. Are the directions asking you to go the composition of F and G or the composition of G and F? Spoiler alert, you have to do them both. You do this way first and then you do that way second. Now write the first equation. So if you're doing the composition of F and G, you write F down. If you're doing the other one, you write G first, right? Draw an arrow to the X, to any of the X's with the second equation. Rewrite the first equation with the second equation substituted in or plugged in for X. Simplify as much as you possibly can. This includes combining like terms. Number 8, this should be your answer. So once you're done simplifying, this is your answer. Check your answer with the teacher and then highlight your answer if it's correct, because you will need that correct highlighted answer to find the domain and range, which is the next step. This is a great place to pause and copy those down. Then we've got number 9. Predict the shape of the graph again. You say we already did that. True, but it might have changed at this point. Number 10, find the domain. What values can X be? This is often all real numbers, so you just want to see if that holds true for your example. Number 11, find the range. So if you predicted that the shape on your graph would be a line, then the range is usually all real numbers as well. But if you predicted that your graph would be a parabola, then you have to find the vertex to find the range, because your range will not be all real numbers. So number 12, to find the vertex, you have to find A, B, and C once your stuff is in the quadratic formula or a quadratic equation. Plug your A, B, and C into x equals negative b over 2a. That's how we find the vertex. 13. So then once you have the x part of the vertex, you're going to use the x from step 12 to plug into the equation from step 8 that you highlighted. And this becomes your vertex completely, the x and the y. Or it's basically step 12 is your x and step 13 is your y. Then for step 14, your range for a quadratic or a parabola will be a set of y's such that y is greater than or less than and equal to whatever step 13 is. Another great place to pause, make sure you have the directions for 9 through 14 written down. Let's do an example so we can see if this makes sense or not. Okay? So as we go through the equations, the problems, I'm going to follow those directions that we just copied down together, right? So again, we're on Module 7. Module 7, Lesson 1, Composition of Functions. Today is still January 13th, 2026. Now, if you're looking at your friend's notes, they're going to have it out of order. They're going to have this first and that list of rules last. It doesn't matter. It'll all be fine. Okay. So I first want to start with how we even read this. So when you see directions that have this F a little circle, G parentheses, and then an X in parentheses, we read that as the composition of F and G evaluated for X. So really be clear here. That is a small circle. It is not an O. This is not the word fog. It is not a multiplication dot. It is a small circle indicating that we're going to do the composition of F and G, that we're going to compose them. We're going to put them together. We're going to put the G in the F and the F in the G, right? We're going to do all this stuff. All right. A really good step is to always predict the shape of the graph. How can we even do that? How would we know what the graph is unless we did the graph, right? Well, okay, using what we know about parent functions. All right, and you've done a couple of activities with parent functions, so you should have an idea of how they work, right? If you need a review of that, let me know. I can make another video. All right, so our first problem says you get the function f of x equals 2x minus 9. You also get the function g of x equals negative 5x plus 6. And we would like you to give us the composition of f and g evaluated for x. And then when you're finished with that, we would like you to give us the composition of g and f, again, evaluated for x. So I'm going to divide my whole paper in half so that I can do this composition on the left and this composition on the right. So looking at my directions, it says to write the f of x and the g of x equations. I did that. Now I need to predict the shape of the graph. 2x minus 9 is linear, so this is going to be a line because this is basically y equals mx plus b format. So the 2 is a positive slope. It's going to be a line that goes up like that, positive slope. Number 3, write the composition order. My order is the f first, then the g. Write the first equation. So I'm going to write f of x equals 2x minus 9. Number 5, draw an arrow to any of the x's with the second equation. So I'm going to draw an arrow to that x with my second equation, which is the g. It is second because it's second in the composition instructions. And so I'm going to write minus 5x plus 6. Step 6 says to rewrite the first equation with the second equation plugged in for x. So I'm going to rewrite this. At this point, if I want to stay complicated over here, I would have to write all of this. I would have to write the composition of f and g according to x. I don't want to, so we're going to call it y equals, and then I'm writing the f of x, so that's going to be 2. But instead of x, I'm writing the equation for g. So we're going to put parentheses minus 5x plus 6, end the parentheses. Now I continue going with my function of x, so I write minus 9. That is the end of where it is Algebra 2 work, because now it is everything you've learned in Algebra 1. You need to take all of those rules to do step 7, which is to simplify as much as possible. So when I simplify, I'm going to start by distributing that 2 to everything inside the parentheses. So I get y equals 2 times negative 5x is negative 10x. 2 times 6 is plus 12 minus 9. Think about it. Why did I not multiply 2 times the negative 9? Right, because the -9 is not inside the parentheses. I would like us to write the words combine like terms. That is part of simplifying, right? So what do I have in here that are like terms that I can combine? I can combine the plus 12 minus 9. This is actually a first grade problem, just 12 minus 9. So we get y equals -10x plus 3. Double check, would it be plus 3 or would it be minus 3? It would be plus 3 because 12 minus 9, the 12 is bigger, so it's positive, right? This is where you check with your teacher and predict again. This is step 8, right? We can even write step 8 out here. Now, I just checked with my teacher and she said that this is correct. We're doing a great job. So I'm going to highlight it, or you can put a box around it. But you want to make sure that when you're looking for the domain and range, that we keep coming back to this equation, not any of the work we've done above it. And then let's predict. This is still in y equals mx plus b format. It is a negative m now, so I'm going to get a line with a negative slope. Okay. My last two steps are to find the domain and the range. So if you can imagine this line, right, on a coordinate plane, right, on an axis, and then we've got this beautiful blue, red line. It goes on forever and ever. I need to know what numbers I can use on the x-axis that will have a value for the red line. Okay, I apologize. I was not even showing. Teaching is so much harder without a classroom full of students. All right, so we've got the x. So I like to just try. If I had x was 0, it would work. There's a point on the line somewhere up there where the line would cross x equals 0. X equals plus 5. Let's pretend that's plus 5. There is a place somewhere right here where the line crosses the line for x equals 5. So both of those numbers work. X can be 0, x can be plus 5. Let's try -5. If it were over here, yes, there is a place up here somewhere where this red line is going to cross the x that will have a value for x. We could keep doing this. -100, way over here, is going to be way up here somewhere, right? Plus 100, well, plus 1,000, it'll be off my paper. But yes, that red line will eventually come in contact with x equals 1,000. Another thing you can do is you can try to find a value for x that would not work. And I cannot think of any. So we're going to get x such that x equals all real numbers, right? So we had that funny R for all real numbers. We'll spell it out on the next one. You could also change this equal sign to be an elements of sign, right? That like circular E, that curvy E that we have. So an elements of all real numbers. Now let's practice the same idea for the range. So the range is all of the y values. So using y, if we go at 0, there the red line does cross, right? So we've got 0. It would be like x is 1 or something, and y is 0. So there is a value for the red line when y is equal to 0. When y is equal to like plus 5 up here, it will also cross the red line right there. So plus 5 works. Let's try -5. If we come down here, we go out for y. There is a value over here somewhere where the red line will cross y equaling a -5. So our range is also all real numbers. So we're going to write y such that y equals all real numbers. We're going to write it out this time in case you don't remember that that's what that funny looking R means. And I'm also going to change my equal sign to an elements of sign to bump it up to our Algebra 2 standards. And then I do want to write out in words what this means so we remember to say such that and just how to read it all. Okay, so the domain is the set of X such that X is an element of all real numbers. And you can write that out again for range if you like. It would read, the range is a set of Y such that Y is an element of all real numbers. And now we're going to go up and do it again. So here, we're going to take g of x equals negative 5x plus 6, and we're going to compose them using the g first and subbing in the f. This would be a great time for you to pause and try it without me. That's what we did in class. If you don't try it without me, you're not going to know if you can do it or not until we have a quiz. That would not be the best time to figure that out, okay? All right, welcome back. So our directions say to write the f of x, g of x. We did that. Predict the shape. Ooh, this is going to be a line again. It has a negative 5x, so it's going to have a negative slope. Negative slope, right? All right. So then we write the composition order. The g is going first. Write the first equation. So I write the g first. G of x equals negative 5x plus 6. Number 5, draw an arrow to the x with the second equation. Our second equation is the f. So we're going to write 2x minus 9. Step 6 is to rewrite this equation. So let's rewrite it. Since I'm combining them now, let's go ahead and change this to a y. Y equals negative 5 times, and then we have the x, but we're putting this in for the x, so 2x minus 9 plus 6. Step 7 is to simplify as much as possible. So I'm going to multiply the negative 5 times everything inside. That's going to give us y equals negative 5 times 2x is negative 10x. Negative 5 times negative 9 is going to be plus 45 plus 6. Be thinking again, how come we did not multiply the negative 5 times the 6? Because the 6 is outside of the parentheses. Now we can combine like terms. What are we able to combine here? The 45 plus 6. So we get y equals negative 10x plus 51. I don't see anything else I can do, so this is where I would go check with my teacher to see if it is correct at this step, and it is. I'm going to highlight it or draw a box around it. You want to do something so that you know this is what we're referring to now to find the domain and the range. All right, we need to check, we checked, and we need to predict. Predicting, this is still going to be a line with a negative slope. All right, our domain is going to be x such that x. All right, if this line goes on forever and ever, and if it is on a coordinate plane, right, with an x and a y, any x will work. That purple line is going to cross all of our values for x. So we get x elements of all real numbers. Now, if you remember in our step 11, where it says find the range, right? It says in a line, it's usually all real numbers. So our range is also going to be y such that y is an element of all real numbers. Because going up or down, this line, this purple line, will eventually go all the way up, 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 to positive 100 and positive 1,000 and positive 1,000,000. And this line is going to go down, down, down to where y is negative 100 and negative 1,000 and negative infinity. So it just goes on forever. So that is your domain and your range. You are finished. So let's go make it more complicated. So this time, our two problems, let's go ahead and start off with Module 7, Lesson 1 continued. Today is still the 13th. All right. First, we write our two problems. Our two problems are the function of x equals x squared minus 4. And then we have g of x equals 6x plus 2. I'm going to divide my entire paper in half because it will take the entire page. On this side, our order is going to be to find the composition of f and g evaluated for x. On the other side, it will be the composition of g and x. Sorry, g and f according to x. Okay. Next step is to predict. So this has an x squared. So thinking of your parent functions, right? Go find one that has an x squared and see what shape it is. It should be a parabola, right? We have a positive x squared, so it should be a positive parabola, a happy face. If we had a negative or a negative number in front of the x squared, then it would be upside down or a frowny face, and that will change our range. So we do need to know the difference. All right. Next step, step 4 says to write the first equation. So writing our first equation, we get f of x equals x squared minus 4. Step 5 says to draw an arrow with the other equation under it. So we get 6x plus 2. Next step is to combine them. When I combine, I usually change it to a y equals x squared. So we're putting this in for x, 6x plus 2, and it needs to be squared minus 4. The minus 4 is the rest of our f of x. There are a couple of ways that you can do the 6x plus 2 quantity squared. I like the box method, so that's what I'll use, but you could also use FOIL method. So box method makes me go 6x plus 2, 6x plus 2, and then we make all of the beautiful boxes. We're multiplying, if you like to put that reminder in the corner. 6x times 6x is 36x squared. 6x times 2 is 12x. 6x times 2 is still 12x. 2 times 2 is 4. Spoiler alert, if you've done it well, these two should be like terms and be able to combine. So we're going to combine all our like terms. We get 36x squared plus 12x plus 12x is 24x plus 4 minus 4. Where do you think we got the minus 4 from? Have a look. Yeah, so the minus 4 is from right here. 6x plus 2 squared was the box method. I did all of this work to get to there. I still need the rest of the equation. So that's where I got the minus 4. Let's write that we're going to combine terms. The only thing I can combine here is the positive 4, negative 4, which gives me 0. So our answer at this point is y equals 36x squared plus 24x. And this is where we check with our teacher and predict again. I am checking, and it is correct so far. I need to predict. I still think it is going to be a parabola. It looks something like this. To find the domain, the domain is going to be the set of x such that. Now, this parabola is going to go on forever and ever and ever and get wider and wider and wider and wider. And so it's going to have all the values for x as well. Like we would have to make it really huge to be able to see them, but it's going to have all the values of x. So we've got x such that x is an element of all real numbers. Our range, however, is not all real numbers, because if this were on a coordinate plane, the way I have it drawn here, it would have to be all numbers bigger than 0. So it would have to be the range is where y equals 0 or bigger, right? But I don't actually know where this parabola sits. I don't know if it sits on this line. So that's why in step 11, it says in a parabola, you find the vertex. So we have to go find the vertex for this highlighted equation so we can figure out where the parabola sits in a graph and decide where it will, what its range will be. So to find the vertex, we start by finding A, B, and C for this equation. So I'm going to leave room for my range here. It's going to be y such that y, but then I don't know how it's going to end yet. I need to find the vertex. So let's write that we need to find the vertex so you know what you're doing. So we're going to go to find the range, find the vertex. To find vertex, use x equals negative b over 2a. To find that, we have to know a, b, and c. Please pause and see if you can find a, b, and c without b. Welcome back. A equals 36, b equals 24, and c equals 0. We don't even have a c. I know that a is 36 because it's standing next to the x squared. I know b is 24 because it's next to the x. Let's add a little bit to our notes up here at the top that standard quadratic form is when 0 equals ax squared plus bx plus c. And these make parabolas. If the a is negative, it makes an upside down parabola, okay? And then slope intercept form, which I love, it is beautiful, is y equals mx plus b, and these are lines, right? So when you see something in this form where the x does not have a squared, etc., it's probably a line, and if it does have a square, it's probably a parabola, depending on if there are other things, but that's a good start. Okay, so now we can plug it in. So we've got x equals negative b over 2a. Our b is 24, so we get negative 24 over 2 times 36. Now I can see from here that I can reduce 24 divided by 2 is 12. So that's going to be negative 12 over 36. If you did not see that, you'll be fine. You'll still be able to do negative 24 over 72 and reduce anyhow. It'll still work. Okay. From here, I still need to reduce. I can see they're both even, so I can reduce by 2. I can actually reduce by 4 because 12 divided by 4, 36 divided by 4. Oh, but I can actually reduce by 12 over 12. So I'm going to reduce by 12 over 12. Again, if you don't see that, you just keep going. Reduce by 2 again, and then reduce by 3. All right. So negative 12 divided by negative 12 is negative 1. 36 divided by 12 is 3. And so our vertex is going to be negative 1/3, but we still have to find the y. So like doing all that work just got us an x. We might as well just go home and cry. Wait. Or, hear me out, we could plug in this x into our highlighted equation, and that will give us the y. And so then we'll have a complete vertex. Yeah. Let's do that. So let's go y equals 36 times negative 1/3 squared, right? Because that's my x, so I'm plugging it in, plus 24 times negative 1/3. Now, I can see that 3 would go into 36, but I cannot reduce first. I have to do the exponent first, right? So let me do the exponent first. So we've got y equals 36 times, and then I'll do this out to the side for anybody who needs it. Negative 1/3 times negative 1/3, right? Because that's what squared is the same thing times itself. Negative 1 times negative 1 equals 1. 3 times 3 is 9. So I'm going to put that in here. Plus 24 divided by 3 would be 8, and it would be a negative 8 because it would be an 8 here. 8 times negative 1 is negative 8. Here we can reduce. Reducing is just dividing. So 36 divided by 9, or 9 goes into 36 4 times. So we get y equals 4 minus 8. Y equals a negative 4. I'm going to take this negative 4 and I'm going to put it in as my vertex. And then the y of our vertex gets plugged in to be the boundary for our range. Okay? Because if you can see it, sorry, looking for an eraser. If you can see it, when I drew this parabola with this little graph here, I just guessed where it would be. Well, it's not going to be sitting on that 0 line. It's going to be at negative 4 and 1/3. So this vertex is at negative 4, right? And where x equals negative 1/3, because that's what this vertex number means, is that the bottommost part or the topmost part of our parabola is at negative 1/3 and negative 4, right? This would be like this. Okay. So now our range, we just have to decide, are the y values all greater than or equal to negative 4? Or are the y values all less than or equal to negative 4? Make a decision, and then we'll put it in there. All of the y values have to be bigger than negative 4. So we're going to write greater than or equal to negative 4. All right? Because all of the y's have to be bigger. If we tried negative 10, the parabola doesn't cross y equals negative 10. So the y's have to be bigger. Okay, now let's do it, the composition of g of x, right? G index. So we write down we predict it is going to be a line. Beautiful, because this is y equals mx plus b. We write the g first. G of x equals 6x plus 2. Beautiful. We draw an arrow and we tell what our other equation is, x squared minus 4. That's what we're going to plug in for x. Change it to a y, and then let's rewrite it, combining the two. So we've got 6 x is now x squared minus 4 plus 2. Right on. Now we simplify, right? We do all of the things that we can do. So we're going to distribute that 6. We get y equals 6x squared minus 24 plus 2. Then we combine like terms. The only thing I can combine are the negative 24 plus 2. So we get y equals 6x squared minus 22. Nothing else I can do, so this is where we check and predict again. Please make sure that you're writing these side notes out here, right? So that when you get to these steps, you know what to do. All right, so I'm going to highlight mine because I checked with the teacher and it is correct. I'm going to predict. I think that I'm going to have a parabola again because it's squared, and it'll be a happy parabola because it's a positive 6. So happy parabola. So for my domain, it's going to be all real numbers because these two go on forever and ever. It'll be every value of x eventually. So x such that x is an element of all real numbers. And then the range is going to be y such that y, and then I don't know because I need to find the vertex to know what my boundary is, right? Like what's my minimum or my maximum so that I know what number the y has to be, in this case, bigger than, right? Okay, so how do we find the vertex? So if I look next door, right, to find the range, I find the vertex. To find the vertex, I use this formula. So let's do find vertex. What does A equal? What does B equal? What does C equal? Using our highlighted equation, right? Pause, try it by yourself. Welcome back. A equals 6. B equals 0 because there is no just an x, and C equals negative 22. Now we plug in x equals negative b over 2a, negative 0 over 2 times 6. We can't do a negative 0, so we get 0 over 12. 0 divided by 12 is, if I have 0 things and I'm sharing them with 12 friends, how many things does everybody get? Everybody gets 0 things, right? So the answer is 0. So for my vertex, x is 0, but we don't know why. I mean, we know why x is 0, but we don't know the value for y in our vertex. So this is where we go home and cry. Or we can plug in x, right? So let's plug in x. We've got y equals 6 times x squared, but x is 0, minus 22. 0 times 0 is 0. 0 times 6 is 0. 0 minus 22 is minus 22. So y equals negative 22. I can put that in my vertex. And then that becomes my boundary, right? That becomes my minimum or my maximum. So I put negative 22 up here. But again, I have to decide, does y need to be greater than or equal to negative 22 or less than or equal to negative 22? Well, when you're thinking about the graph, way down here at negative 22 and 0, that's where my parabola's vertex is. At negative 22, all of those values for y need to be greater than. So y has to be greater than or equal to negative 22. Right on. Homework is page 97 in your workbook, just numbers 1 and 2. Do not freak out that you don't have your workbook at home because I posted this in Google Classroom as well. So this is in the announcements. Go try 1 and 2 without me. See if you can do them on your own. I know it's a lot of work, but you've got this.